Hello dear students, I am continuing the exercise chapter 13 limits related to limits. So some special type of limits were also required for finding limits. So let us start. Okay. Algebra, that means addition, subtraction, multiplication, division, etc. So here also, if we are having two functions, then how can we find the limit of addition, subtraction, multiplication, division? They are called algebra of limit. That is, if we are having function fx and function gx, two function, its limit extending to a equals to something, suppose L1. Its limit extending to a, suppose having L2. Both function are having common domain. Then algebra means fx plus or minus gx. Fx plus gx, the limit of this separately exists L1 L2. Then the limit of x tending to a, this will be what? Just you can distribute it. That is like this. Limit x tending to a, fx plus minus limit x tending to a gx. Proof is not required, just you must know this. Okay, fx plus gx, just limit are distributed and x tending to a, both x tending, because fx and gx are having common domain. Plus, then plus, minus, then minus. And now, suppose there is a constant value k. Suppose there is a constant value k into fx, then limit x tending to a, then limit x tending to a, limit x tending to a of this. So this is constant value, so constant can be taken outside the limit symbol. Okay, so here we can write like this, constant into limit x tending to a fx. Okay, these are the algebra of limits, addition, subtraction, and this is scalar multiplication of function. Similarly, x tending to a, common domain having fx and gx, so fx into gx. Two function are multiplied. So you can separately take limit and multiply. So this is equals to, also we can write like this, x tending to a fx into limit x tending to a gx separately. Okay, so this, by using this you can find if its limit L, its limits L2, then is L1 plus minus L2. It's a into L1. It's L1 into L2. Clear? Now, final what? Limit x tending to a fx upon gx. Here, gx should not be equals to 0 for the common domain. Just this is equals to, also you can distribute limit in numerator and denominator. Okay, just limit distributed to limit numerator and denominator like this. Limit x tending to a fx upon limit x tending to a gx, L1 upon L2, provided gx is not equals to 0, or also limit gx is not equals to 0, provided is not equals to 0, limit gx not equals to 0, provided limit extending to a not equals to 0, provided this lower part is not equals to 0, L2 is not equals to 0. So division you can distribute. In the case of division, just see denominator should not be equals to 0, and product distribute. Here constant taken outside and plus minus distribute. So these are the algebra of limit. We can follow this rule for these properties or algebra of limits for finding the limit of a given function. Okay. And trigonometric, also you can use trigonometric identities for finding limit, for trigonometric function related to trigonometric identities, trigonometric functions. Just we can use all the trigonometric functions, trigonometric identities for reducing the function, and finally just put the value of variable, that is at which we require the limit. Okay, so just remember all the trigonometric formulas. Sin c plus dc minus d cos c plus d cos c minus d, and so etc. Many formulas are there. So just all the formulas can be used for reducing function, trigonometric functions, to a particular form at which we can find limit by putting the required value of the variable. Okay. So some special formula are there. Just remember and note down all this formula. Okay, first limit x tending to a, x to the power n minus a to the power n upon x minus a is equals to n a to the power n minus 1. Clear? This is, here a is positive. Here a is positive. A is positive. Okay. So this is a special formula. This type of formula, there are 5, 6, 7 formula are very important for finding limits of different type of function. Okay, here we see that also a is greater than 0, positive value a, and n may be also rational, integral, and also may be rational value, 1 by 2, 3 by 2, 4 by 2 also. Okay, so proof is very simple. We know that x power n minus a power n, just factorization, a square minus b square, a cube minus b cube, a power 4 minus b power 4, just power n. So we can write like this, x minus a and 1 less power n, so n minus 1 and n minus 2, that is this, plus x power n minus 2 into a plus x power n minus 3 into a square plus, and so on. Last term will be a power n minus 1. This formula comes from just like this, a square minus x minus a, x plus a, x cube minus a cube, x minus a, x square plus, and so on, just like this. Okay, so this type of factorization can be used for finding these limits. So here we see that x power n minus a power n by x minus a, this factor can be taken here and right hand side is like this, x to the power n minus 2a plus and so on up to a to the power n minus 1. Clear? Now take limit on limit extending to a, x power n minus a power n upon what? X minus a. So this is equals to just limit take. So here taking limit. So limit x tending to a, x to the power n minus 1 plus x to the power n minus 2 into a plus x to the power n minus 3 into a square plus and so on up to a to the power n minus 1, just like this. Okay. Distribute, because we know algebra of limit. So distribute the limit x tending to a, x to the power n minus 1 plus limit x tending to a, x to the power n minus 2 into a plus and so on. Limit x tending to a to the power n minus 1. Here nothing is related to x, so limit will be a to the power n minus 1. Just see here, whenever find the limit x tending to 2 and 5, so what will be the value? 5, because there is no x. So x tending to 2, it is not required. So 5 is 5. Similarly, constant term function having limits as a constant. So this a to the power n minus 1, positive value a to the power n minus 2 into a plus third term a to the power n minus 3 into a square plus up to a to the power n minus 1. So just we see that a to the power n minus 1 plus a to the power n minus 1 plus a to the power n minus 1 plus and up to a to the power n minus 1. So how many times? n times. Because n minus 1 here just power adjusting n minus 1 how many times? N times. 1, 2, 3 up to just like final last power or 0. So 1 and n minus 1 to this having how many terms? N terms. So n a to the power n minus 1. So limit of this is equals to n a to the power n minus 1. So this is the first limit. Okay, formula. Second formula, just we have proved now. Second formula is limit x tending to 0 e to the power x minus 1 upon x equals to 1. Second formula is this. X tending to 0 x minus 1 by x equals to 1. We have proved it just now by using series. Similar formula for a to the power x power. Okay, you know a to the power x. Here also the series for a to the power x is just like e to the power x. What is the value of e to the power x? 1 plus x square upon 2 factorial x cube upon 3 factorial plus and so on. This is our series 1 factorial. These are e to the power series. So a to the power x is a special value. So here a to the power x series is same. Just in place of x, write x log a. Nothing is there means log a to the base e. Whenever we just not write anything at the base, that is base is e, that is the e. So here a to the power x is what? 1 plus x log a. In place of x, just write x log a. So this plus x log a square by 2 factorial plus, just in place of x, write this is formula for a to the power x. So here we can also see that if we use this formula for this limit, third limit x tending to a, not a, x tending to 0, I think x tending to 0, okay, 0, a to the power x minus 1 upon x, just e to the power x minus 1 upon x, one limit, here for limit x tending to 0, a to the power x minus 1 by x is equals to what? Log a. Okay, this is log a. Clear? So, remember this formula. These three formula and also some formula there here, because this minus a to the power x minus 1 by x, so this minus 1 by x, so 1 cancel, 1x cancel, so first term log a and all terms 0, so log a. Okay, so this is the third formula. Now fourth formula is, just we know binomial theorem, okay, all the formula of given list is what? Binomial theorem. Here, fourth, limit x tending to 0, 1 plus x power 1 by x is equals to also, value is exponential e. E means what? Just e to the power x equals to what? 1 plus x square by 2 factorial plus x cube by 3 factorial plus and so on up to infinity. Now if we put x equals to 1, then 1 equals to 1 plus, in place of 1 plus 1 upon 2 factorial plus 1 upon 3 factorial plus and so on. This is e. E to the power 1 means e. So its limit is e. Okay. So it can be also proved by using binomial expansion. Okay, so see here, how can you prove it? We know binomial theorem, what? 1 plus x power n equals to 1 plus nx plus n minus 1 by 2 factorial n by 1 factorial x square plus n minus 1 n minus 2 by 3 factorial x cube plus and so on. So this is the formula for binomial expansion. Clear? This is formula. Okay. N, where this is binomial theorem for mod x is less than 1. It is defined for mod x is less than 1, because in the just provided list of expansion. We see this is binomial expansion. This expansion can be used for finding this value. How? 1 here we see this is equals to, so 1 plus x or 1 by x. This what's limiting value at x tending to 0, no? So 1 plus x power 1 by x in place of n. Here what is 1 by x? Just use this formula. 1 plus n means 1 by x into x plus n minus 1, that is n means 1 by x minus 1, n minus 1 upon 2 factorial into x square plus n minus 1 n minus 2 upon 3 factorial x cube, just like this we get. Okay, so now see, this is equals to 1 plus 1 plus, here just see, taking LCM, x square, do you know what x square, cancel out, so 1 minus x, 1 minus x upon 2 factorial plus, here taking LCM, 1 minus x, 1 minus 2x, x cube cancel, so 1 minus x, 1 minus 2x upon 3 factorial up to infinity. Okay, now this is 1 plus x to the power 1 by x. Now its limit extending to 0, just you can put now x equals to 0 here. Okay, so this limit extending to 0, 1 plus x to the power 1 by x is equals to, if x equals to 0, then 1 plus 1 plus 0, 1 by 2 factorial plus 1 by 3 factorial plus and so on. And this is what? This is equals to E. So this is formula. So limit extending to 0, 1 plus x to the power 1 by x equals to E. Clear? So this is fourth special limit. Now also fifth limit is, so these are this formula you have to remember. All formula are very important for finding limit. Okay. Now fifth limit, this 1, 2, 3, 4 and fifth limit is also there, that is fifth limit extending to 0 log 1 plus x upon x equals to 1. Log 1 plus x upon x extending to 0 equals to 1 also. So this is also important limit. Log 1 plus x upon x tending to 0. Just we can see that here 0, log 1 0, 0 by 0 form. So just for finding this limit we can use series form. Just we have provide the list of some series, basic series, we can use that for finding limit. So here also we can see that its limit log 1 plus x upon x, its limiting value x tending to 0. So here log 1 plus x series x minus x square by 2 plus x cube by 3 minus x power 4 by 4 plus and so on. This is the value of log series form of log 1 plus x. Okay. And x is there. Now you can take common x from numerator and then cancel out. So this is equals to what? 1x cancel out. 1 minus x by 2 plus x square by 3 minus x cube by 4 up to infinity upon x, that is 1 minus x by 2 plus x cube by 3 log 1 plus x by x. So this is equals to, now if we apply limit on this, so this tending to what? All the terms will be 0, so 1. So this tending to 1 as x tending to 0. This tending to what? 1 as x tending to 0. Then all will be 0. So 1, 1. So this tending to 1. Limit 50. Okay. So these are the important formula for finding limit of given function. Also trigonometric limit is there, sin x cos x, sin and tan. Just we will use that. Limit 6, limit x tending to 0 sin x by x equals to 1. Limit x tending to 0 tan x by x equals to 1. So these two trigonometric limits are very, very important also. Proof is very simple. You can use series, sin series, tan series. Cancel out the first common x from numerator to denominator and limit will be cancelled. The x will be cancelled and then you can put the value of x as a 0. Then you can get the limit 1. So very simple. Just like sin series, we know sin series what? Here, sin series is sin x equals to what? X minus x cube by 3 factorial plus x power 5 by 5 factorial and up to infinity. Series form, just we know. Okay, this is, so sin x by x. Here, just taking one sign common, 1 minus x square by 3 factorial x 4 by 5 factorial and up to infinity and divided by x. So this tending to what? Also 1. Why? 1x cancel, just put x equals to 0, so remaining parts will be 0 except 1, so limit will be 1. Similarly 10x. Similarly you can use 10x series. Then you can get also 10x by x limit 1 as x tending to 0. So sin x by x as x tending to 0 is limit 1. So remember this a special limit 1, 2, 3, 4, this 5, this 6, this 7, all are formula. You can use it. Just like suppose we are having sin 2x by x, limit x tending to 0. Just we have to find this. Here remember that sin 2x. So one thing, just you can substitute like 2x equals to t. Suppose here x tending to 0. So as x tending to 0, if x tending to 0, that this is also tending to 0 because 2 into 0 into 0. So 2x tending to 0, that is t tending to 0. T tending to 0. As x tending to 0, t tending to 0. So just substitute here. Limit x tending to 0, we can write t tending to 0. Okay? But in this case, first of all, write sin 2x upon 2x into 2. Just set like this. Same thing. 2x. So 2 multiply 2 numerator and denominator like this. Now this is equals to what? Limit t tending to 0. Limit t tending to 0. As x tending to 0, you can write t tending to 0. And 2x t. So sin t upon t into 2. Limit t tending to 0, sin t upon t, limit t tending to 0, 2. This is constant. So there are two limits like this. So we know this is equals to 1 by using this formula. X, so 1. And this is constant, so 2. So this is equals to 1 into 2 equals to 2. Its limit is 2. Okay, so we can set out like this substitution. Now 10x limit can also be do by using, and here also remember that sin x tending to sin x tending to 0 as x tending to 0. Also if x equal to 0, then sin 0 equal to 0. Similarly cos x tending to 1 as x tending to 0, cos 0 equal to 1 also. So just remember this, and from this you can find 10x by x limit also 1. How? Just solve 10x by x. We have to find the limit of this as x tending to 0. So this can be written as sin x upon cos x into 1 by x. So we can write sin x by x into 1 by cos x. So limit sin x upon x, limit x tending to 0, 1 upon cos x, limit we can write now limit x tending to 0, 10x by, just we can write like this, 10x by x. So limit x tending to 0, 10x by x equal to this. So limit of this is equal to limit of this into limit of this. by algebra of limit. So this is equals to 1. And here limit extending to 0, limit x distribute to numerator and denominator. Here will be 1, and here cos x equal to 0, 1, 1. So this is 1, this is 1, equals to 1. So 1 into 1 equals to 1. So this is the one limit. So by using series and also using this C7 formula, you can find different type of limits given in your book. Okay, so remember these are the formula for finding limit. Okay. And also one thing, remember that if we have to function fx is less than equal gx, then limit extending to a fx is less than equal limit extending to a gx. Okay, fx and gx having both common domain for all x belongs to D, and a is the point. If fx is less than equal gx, then its limit is less than equal its limit. Okay, and here another theorem is called what? Sandwich theorem. Just like suppose we have three functions. Three functions are there having common domain for all x belongs to domain of the function, and its two limit fx and hx, and limit extending to a fx equals to limit extending to a hx. There are three functions, its limit and its limit, both are equal to L. Then in between function gx having also limit L, then limit extending to a, if these three functions are like this, then if fx and hx having same limit, then limit of gx is also that same limit. Okay, so this is also important theorem. By using this we can prove this limit also in a different way. Okay, so remember all this formula of limit. Now we will solve questions from exercise 13.1 one by one. So take some questions from exercise. All formulas are important, so note down all this. Here one supplementary exercise is also there. So here first of all, just we understand some process of finding limit. So first we take this exercise, supplementary exercise, very very important, and just that is in NCERT book, in the at the end of the book it is given supplementary exercise 13.2. So important to solve its question one by one. 4-5 questions are there. Okay, question 1. So find limit. What? It is 4x minus 1 x tending to 0. So first question. Limit x tending to 0 e to the power 4x minus 1 upon x. We have to find its value. Okay, what is the value of this? Because just I have discussed now the special type of formula, so this is supplementary exercise you can solve. 13.2 supplementary exercise. So this question, finding the limit of this. How can you find the limit of this? Let's see here. We know formula, but it is over x minus 1 upon x tending to 1 as x tending to 0. We can write like this or also like this. Limit x tending to 0 e to the power x minus 1 upon x equals to 1. This or this. We can write like this. So by using this we can find its limit. But here 4x, so here we see that single thing x, x, x. So single quantity must be there. So here x, x, here 4x. So our target is what? X tending to 0, then 4x also tending to 0. Because in 3 places there are x. So we can also write like this. Limit t tending to 0 e to the power t minus 1 upon t. Same thing will be there. Okay. So here limit x tending to 0 e to the power 4x minus 1 upon 4x into 4. We can write like this. So 4x, 4x, here only x. Now, as x tending to 0, 4x is also tending to 0. Because x tending to 0, that is 4x, 4 into 0 equals to 0. So 4x also tending to 0. So we can write it like this. This is equals to limit x tending to 0. So 4x also tending to 0. X tending to 0, 4x tending to also 0. So e to the power 4x minus 1 upon 4x into 4. So it can be written t tending to 0 e to the power t minus 1 upon t into limit t tending to 0, 4 equals to 1 into 1 equals to 4. This is 4. Its limit will be 4. Just see, this is formula. So 4x, 4x, 4x can be written. You can also write the value of this direct 1 by using this limit. So if this is t, this is t, this is t, then you can put 4x equals to t, single quantity. Now t tending to 0, it is over t minus 1 by t, 1 into limit t tending to 0, 4, 4 is constant, so 4 is 4, 4. So limit is 4. Okay. Similarly, second question, it is over 2 plus x minus e square. The supplementary exercise, how can you find limit by using a standard formula here? Just it is over 2 plus x minus, second question, 2 plus x minus e to the power 2 upon x, limit x tending to 0. Limit x tending to 0, this we have to find. So here 2 plus x, so we can write like this. Just try to convert it in this form. So here e square, e to the power 2 into e to the power x minus e to the power 2 upon x, we can write. So here limit x tending to 0 e to the power 2 comma e to the power x minus 1 upon x. So e to the power 2 is free from x, so e to the power 2 can be write like this, limit as a constant multiplication, this x tending to 0 e to the power x minus 1 upon x, so e to the power 2 into 1 equals to e to the power 2. Okay, so using this formula you can find limit e to the power x minus e to the power 5. Third question, e to the power x minus e to the power 5 upon x minus 5, e to the power x minus e to the power 5 by x minus 5. Okay, so for finding limit of this as x tending to 5, limit x tending to 5. Then here just we see that x equal to 5, 0, 0, 0 by 0 form. So we will try to find the limit of this function by converting in this form. So here we can put x equals to 5 plus h. Limit x tending to 0 e to the power x minus 1 of x equals to 1. Now, for finding this limit x tending to 5, because if we want to use this limit, this formula, so here x tending to 0 is here x tending to 5, so we substitute like this. Then if x tending to 5, then new variable, just h tending to 0, because x tending to 5 means here 5 cancel, x tending to 0. So put x tending to x equal to 5 plus h, then as x tending to 5, h tending to 0. If x equal to 5, then 5 cancel, h tending to 0. So 0. So use this here. So limit x tending to 5 e to the power x equals to 5 plus h. 5 plus h minus e to the power 5 upon x minus 5. Clear? Now x equal to 5 plus h. X equal to 5 plus h. That is x tending to 5, h tending to 0. Now here e to the power 5, e to the power 5 can be taken common. E to the power h minus 1 upon here x means 5 plus h. 5 plus h minus 5. So we get e to the power 5 constant. So like this, limit h tending to 0 and e to the power h minus 1 upon h. So this is same as this. So this is equals to 1. E to the power 5 into 1 equals to e to the power 5. So this is answer. Okay. So e to the power 5 now. How can we write the formula for trigonometric function? Just see question 4. Okay, it is a sin x minus 1 by x. 4. Limit x tending to 0 e to the power sin x minus 1 upon x. Just we have to find the value of this limit. So here we see that how can we write it? Its limit is what? 1. We can say because here x tending to 0, this quantity tending to 0, this quantity tending to 0. X tending to 0, that is this quantity tending to 0, this quantity tending to 0. So here same thing is this. X tending to 0, this quantity tending to 0. If x tending to 0, we know also this tending to 0. So its limit should be 1. So it can be solved, it can be found by using other all the required formula here also. Limit x tending to 0 sin x upon x is equals to what? 1. We know this formula. Just we will use our basic, just this type of formula. Give formula on the right hand side. Okay. So limit x tending to 0. Here we can write sin x minus 1 upon sin x into sin x upon x. Here x equal to not 0. That's why we can do like this. Just x is denominator, sin x multiplied by sin x into numerator and denominator. Now, limit x tending to 0 e to the power sin x minus 1 upon sin x by algebra, limit x tending to 0 sin x by x by using algebra of limit. Here limit y tending to 0, if we put sin x equals to y, then as x tending to 0, y tending to 0. If sin x equals to y, in first, just write one time x tending to 0 e to the power sin x minus 1 upon sin x and into 1. This is 1 by using formula. Now in this sin x equal to y, in place of sin x we just put y. Then as x tending to 0, as x tending to 0. Just sin x tending to 0, so y tending to 0, so y tending to 0. So we can write limit y tending to 0 e to the power y sin x y minus 1 upon y is equals to 1. Again using this formula y. So limit is 1. Okay. Now next question is same as question third. Question fifth is simple. X tending to 3 is there, na? So question 5, limit x tending to 3 e to the power x minus e to the power 3 upon x minus 3. So it is simple, just like third question. Here put x equals to 3 plus x. Put x equals to 3 plus h. As x tending to 3, h tending to 0. So it can be written what? H tending to 0, x e to the power 3 plus h minus e to the power 3 plus h minus 3. So h tending to 0, e to the power 3 e to the power h minus 1 upon h. So e to the power 3 limit h tending to 0 e to the power h minus 1 upon h equals to e to the power 3 into 1 equals to e to the power 3. Same question, okay. And remaining question, one question is there, 6, 7. No, here log 1 plus 2x by x. Log 1 plus 2x by x. 6. Limit x tending to 0 log 1 plus 2x by x. 1 plus 2x by x. We know related to logarithmic formula. What is the formula? Log formula is since limit log 1 plus x upon x equals to 1. Here base is e, nothing means e, just here. Okay, so using this formula we can find the value. Here 2x, just we can use limit x tending to 0, just log of 1 plus 2x upon 2x into 2. So this can be written like this, 2x tending to 0 log 1 plus 2x upon 2x into limit x tending to 0 2. Okay, this just 2 multiplying numerator and denominator. Now here 2x, so we can write limit t tending to 0 log of 1 plus t upon t, near 2. So 2, 1 into 2 equals to 2. This is the formula, log 1 plus x. Single quantity should be there, x. So here 2x, so 2x, 2, adjusted 2x, x tending to 0, 2x also tending to 0. So 2x equals to t. 2x equals to t. 2x equals to t. Put as x tending to 0, t tending to 0. So this is the solution. Answer 2. Okay. Now log 1 plus x cube by sine square x 7. Just adjusting only in the standard form of standard formula. Okay. So limit x tending to 0 sin x by x equals to 1. Also you can use this formula. The standard formula you have to use for finding the limit. Okay. So here question, just 8 question. Limit x tending to 0 log 1 plus x cube log 1 plus x cube upon sine square x, sine square cube x, sine cube x, sorry, sine cube x. Clear? Just we have to find this limit. Now here see that limit x tending to 0, just convert in terms of standard form. So log 1 plus x cube upon x cube into x cube upon sine cube x. We can write like this. Just multiply by x cube in numerator and denominator. Now separate limit. Limit x tending to 0 log 1 plus x cube upon x cube and limit x tending to 0, we can write 1 upon sine qx upon x cube. It can be written like this. Okay, so here limit x cube tending to 0, as x tending to 0, x cube tending to 0, so this tending to 0, log of 1 plus x cube upon x cube, limit x tending to 0, one upon sin x upon x cube. Put x cube equals to y. As x tending to 0, y tending to also 0. X tending to 0, then x cube tending to 0, that is y tending to 0. So just put here y tending to 0. Limit y tending to 0 log 1 plus y upon y. Just x cube, x cube, x cube, y. So this formula is used. 1 here, 1 upon limit of sine x upon x, x tending to 0 cube equals to 1 into 1 upon 1 cube. You can write like this also. Okay, so this is equals to 1. So limit is 1. Clear? Limit is 1. Now this is up to 8. Exercise 13.2, supplementary exercise. So a special formula for finding limit are very, useful. This will help also for finding derivatives. Okay, so 13.2 supplementary exercise is completed by this special formula, and in the next class we will discuss about solution of 13.1 questions from 13.1 exercise. Okay, just do all these questions in your copy and send me some solutions for your attendance. Okay.